This is my non-homogeneous equation sample problem, which is y double prime plus 4y prime plus 3y is equals to sine x. For the solution, we must first transform this non-homogeneous equation to homogeneous by taking the left side of the equation and equating it by 0. So, we got the y double prime plus 4y prime plus 3y is equals to 0. Then next, we must transform it into characteristic equation, which is ar squared plus br plus c is equals to 0. Then, substituting all the real numbers below, which is 1r squared plus 4r plus 3 is equals to 0. Then, we must factor it out. So, the factor is r plus 1, then r plus 3. Then, after we got the factor, we can say that our first root is equals to negative 1 and the second is negative 3. Then next, we must use the complementary solution, which has the formula y sub c is equals to c sub 1 e raised to the power of r sub 1 x plus c sub 2 e raised to the power of r sub 2 x. Then let's substitute the first root and the second root in the complementary solution. Then we will get the equation y sub c is equals to c sub 1 e raised to the power of negative x plus c sub 2 e raised to the power of negative 3x. Next, we must get the particular solution. So using the formula, the equation y double prime plus 4 prime plus 3y is equals to sine x. Then, let's assume that our particular solution is yp is equals to a sine x plus b cos x. Then, the first derivative for that is yp prime is equals to a cos x minus b sine x. Then, the second derivative is yp double prime is equals to negative a sine x minus b cos x. Then, we must substitute the particular solution in the equation. So, we will get the negative a sine x minus b cos x plus 4 quantity a cos x minus b sine x plus 3 a sine x plus b cos x equals to sine x. Then, we must equate or simplify the equation. So, we will come up with 2a sine x minus 4b sine x plus 2b cos x plus 4a cos x is equals to 1 sine x plus 0 cos x. Then, we must factor out the constant, which is the negative 2a minus 4b sine x plus 2b plus 4a cos x is equals to 1 sine x plus 0 cos x. Then, we must add the first equation and the second equation. So, our first equation is the 2a minus 4b is equals to 1. Then, 4a plus 2b is equals to 0. So, we must multiply the first equation to negative 2 so that we can cancel out one variable. So, after multiplying the negative 2 in the first equation, we should get the negative 4a plus 8b is equals to negative 2. Then, the second equation, which is the 4a plus 2b is equals to 0. Then, add the two equations, we will get the 10b is equals to negative 2. Then, we must get the value of b. So, we will divide both sides by 10. So, b is equals to negative 2 over 10, or the lowest form is negative 1 over 5. Then, since we have the value of b, we must substitute it in the first equation to get the value of a. So, 2a minus 4, quantity negative 1 over 5 is equals to 1. So, 2a plus 4 over 5 is equals to 1. Then, transpose it to the other side. So, 2a is equals to 1 minus 4 over 5. Then, divide both sides by 2. So, we should get the value of A. So, A is equal to 2 over 5. Then, substitute the value of A and B in the assumed particular solution. So, yp is equal to A sin x plus B cos x. Then, the value of yp, or the particular solution, is 2 over 5 sin x minus 1 over 5 cos x. Then, to get the value of the general solution, we must add the particular solution and the complementary solution. So, our complementary solution is the y is equal to c sub 1 e raised to the power of negative x plus c sub 2 is equal to negative c sub 2 e raised to the power of negative 3x. Then we should come up with our general solution. So y is equal to c sub 1 e raised to the power of negative x plus c sub 2 e raised to the power of negative 3x plus 2 over 5 sin x minus 1 over 5 cos x.
Good day. Shown here is my example for non-homogeneous equation, which is y double prime minus 7y prime plus 10y equals cos x. First, let's get the complementary solution using the left side of the equation, which is y double prime minus 7y prime plus 10y equals 0. Now, let's turn that into, let's get the characteristic equation, which will be AR squared. The characteristic equation of this complementary solution, or this y double prime minus 7y prime plus 10y is equals to 0, which will be AR squared minus BR plus C equals 0. Now let's put the value of this equation. So because we don't have the value of y, so we'll put 1r squared, and the b is 7, so 7r plus c, the c is 10, so equals 0. Numbers that have the sum of negative 7 and the product of 10 will be negative 5 and negative 2. So our roots will be the r1 is equal to 5 and the r2 is equal to 2. So this is the formula to get the complementary solution. So y sub c is equals to c sub 1 e raised to r sub 1 of x plus c sub 2 of e raised to r sub 2 of x. So because our r1 is 5 and the r2 is 2, so let's put those values in this one. So y sub c is equals to c sub 1 of e raised to the power of 5x plus c sub 2 of e raised to 2x. Okay, proceeding to the particular solution, assume that y sub p is equals to a cos x plus b sin x. Now get the derivative of the y sub p. We'll have the derivative of a cos x plus b sin x. It will be negative a sin x plus b cos x. And the second derivation, or the double derivative of a cos x and the b sin x, is equal to negative a cos x minus minus b sin x. Now, apply all the values in the original equation. We will have the quantity of negative a cos x minus b sin x minus 7 to the quantity of negative a sin x plus b cos x plus 10 to the quantity of a cos x plus b sin x equals cos x. Now, combine like terms, we'll have here, let's more focus on cos x because we have equals cos x here. So, here we have negative a cos x and negative a cos x and 10a cos x. So, let's add that. We'll have 9a cos x. Because we have here the negative 7b cos x, let's put that here. So it will be negative 9a cos x minus 7b cos x plus, let's proceed to sin x. Here we have negative b sin x and here we have 10b sin x. So we'll have 9b sin x plus, here negative times negative is equals to positive. So plus 7a sine x equals, guess that 1 cos x plus 0 sine x. Now let's get rid of the cos x and sine x. So here, because we have the same same sign or same triangle, let's put 9a minus 7b, the quantity of 9a minus 7b cos x plus the quantity of 9b plus 7a sin x equals, copy this term, and because 1 is our cos x and 0 is our sin x, apply it to the equation, and it will be 9a minus 7b equals 1, or the cos x, and the 7a plus 9b equals 0. By equating the equation, we'll have 9a minus 7b, the equals 1, so transfer it here, so it will become negative 1 equals, the 0 is 7a plus 9b, so we'll put 7a plus 9b here. Now let's transfer the 7b here and then 7a here, so we can add the same variable or subtract the same variable. So we will have 9a minus 7a minus 1 equals 9b plus 7b. So combine like terms, just what I've said. So 9a minus 7a is equals to 2a minus 1 equals 16b. Now let's multiply the equation to 1 over 16 to get rid of the 16 here, and we'll have the value of b. Here we have our b equals to 2a minus 1 over 16. Now let's get back to the first equation, which is 9a minus 7b equals 1. So 9a minus 7, because we have the value of b, let's put 2a minus 1 over 16 here equals 1. So 9a minus, because 7 times 2a, negative 14a plus 7 over 16 equals 1. So let's get rid of the denominator. So let's multiply the general by 16. So we'll have 144a minus 14a plus 7 equals 16. So because we have the like terms here, we subtract it because the one is positive, the one is negative. So we will have 130a is equals to 9. This is 9. This is 9. So because we will get the value of a, let's divide 138 by 130. Divide both sides by 130. So it will be a is equals to 9 over 130. And because we have the value of a here, the value of b is equal to 2a minus 1 over 16. So let's put the value of a, which is the 9 over 130. So 2 times 9 over 30 minus 1 over 16. We'll have the answer of 7 over 130. So sin x. Let's put the value of a to cos x and the b to sin x. And we will have 9 over 30 cos x minus 7 over 130 sin x. Or we have our y sub p is equals to 1 over 30 to the quantity of 9 cos x minus 7 sin x. Here we have the general solution, and which will be y is equals to yc plus yp, or y sub c is equals to y sub p. Our yc is c sub 1 e raised to the power of 5x plus c sub 2 e raised to 2x here, plus 1 over 30 to the quantity of 9 cos x minus 7 sin x.
The other problem is y2 prime minus 28y prime plus 27y equal x squared plus x. So this given, we will solve this by using the variation of parameters. So the general solution is yx equals ypx plus ycx. And the complementary solution is yc equals c1e 27x plus c2ex, and the yp equals u1 y1 plus u2 y2. So the u1 here is the c1 and the y1 is e27x, and the u2 is c2 while the y2 is ex. So we will going to find the u1 and u2. To find this, we should have the condition. Condition is u1 prime y1 plus u2 prime y2 equals 0. So substitute the yc, it could be u1 prime e27x plus u2 prime ex equals 0. So yp equals u1 e27x plus u2 ex. We should derive this using the product rule. So the value of this is y prime p equals u1 prime e27x plus u1 e27x times 27 plus u21 ex u2 ex. So this u1 prime e28x will cancel this, and u prime 2 ex. So the remaining is up prime equals 27 u1 ax plus u2. So after this, we will derive again using the product rule. So the answer is up 2 prime equals 27 u1 prime e plus 2 u1 e to the 7 x times 27 plus u2 ax plus u2 ax. So again, we will derive this. So the answer is y2 prime minus 28 y prime plus 27y equals x2 plus x. And now we will derive this using the product rule. So the answer is 27 u prime 1 e to the 7x plus 729 u1 e to the 7x plus u prime 2x plus u2 ex minus 28 times 27 u1 e to the 7x plus u2 xx plus 27 times u1 e to the 7x plus u2 x equals x squared plus 2. So using the combination, this, so equivalent for this is 0, so we will cancel out this. So the remaining is 27 u1 prime e to the 7 times x plus u prime 2 ax equals x squared plus x. And now we will have the two equation, this one and this one. So to solve this, we will use the elimination of variables. So the first variable is this and the second this. So the second variable we will multiply it by negative 1 and solve. So the answer of this is 26 u1 prime e 27x equals x squared plus x. And divide it both sides, so the answer is u1 prime equals x squared plus x over 26e 27x. After this, we use the integrals, so the answer is u1 equals negative 79 x squared plus 783x plus 29 over 111758e27x plus c. So this is our u1. So now we're going to find the u2. So to find u2, we will use as the u1. So this first x squared plus x over 26e 27x times e 27x plus u2 prime ax equals 0. So cancel out this and this, then transport the x squared plus x. So the answer is u2 equals x squared plus x over 36ax. And then we use the integral, so the answer by using the integrals is u2 x squared plus 3x plus 3 over 26ex plus c. So now we find the u1 and u2. So we will back to yp and substitute the u1 and u2. So the value of this is yp equals 729x to x squared plus 703x plus 29 over 511753820x times e27x plus x squared plus 3x plus 3 over 26 ax times ax. So we will cancel out this 4 and this. The answer is, and the remainder is yp equals negative 729 times x squared minus 783x minus 29 plus 19683 x squared plus 59049x plus 59049 over 511758. So after this, we will transport this to be a fraction. So the answer is yp equals 18954 times x squared plus 5826x plus 59020 over 511758. Next, we will transport now. So y 18954 over 5117558 equals 1 over 27x squared, and then 58266x over 5117558 equals 8379879x, and last 59020 over 511758 equals 227019683. And then we will combine the yp and now, so and complementary solution. So the answer is yx equals 1 over 27 x squared plus 83 over 279x plus 2270 over 19683 6A3 plus C1A2 7x plus C2A so x. So this is our the final answer.